Welcome. In this video, we will learn how to prove whether an argument is valid, understand quantifier used in logic, and explore how Venn diagram help test logical argument. By the end, you will be able to analyze argument using different logical method with confidence. In logic, an argument is not a quarrel or disagreement. It is a group of statements where some statement called premises provide reason for accepting another statement called the conclusion. The goal of logic is to determine whether the conclusion truly follows from the premises. Every logical argument has two main parts. The premises contain the evidence or reason. The conclusion is the claim that follows from those reasons. We often identify the conclusion using words like therefore, thus, or hence. Consider this example: all humans are mortal. Socrates is a human. Therefore, Socrates is mortal. The first two statements are premises and the last statement is the conclusion. Since the conclusion follows logically from the premises, this is a valid argument. An argument is valid if it is impossible for the premises to be true while the conclusion is false. Validity depends on the logical structure, not on whether the statements are actually true in real life. Argument form is logical pattern behind an argument. Instead of using specific names or objects, we replace statement with symbols such as P, Q, and R. This allows us to study the structure of reasoning. Look at this argument. If it's rain, the ground gets wet. It is raining, therefore the ground is wet. Its logical form is if P, then Q. P, therefore Q. Many different arguments can share this same logical pattern. Logic focuses on pattern rather than specific topics. If the argument forms is valid, then any argument built using that form is also valid, regardless of the subject. Rules of inference are standard pattern of reasoning that help us reach correct conclusion. They provide step-by-step method for proving argument logically. One of the most common rules is Modus Ponens. If P implies Q and P is true, then Q must be true. This rule is simple, reliable, and widely used in mathematics, science, and computer programming. Another important rule is Modus Tollens. If P implies Q and Q is false, then P must also be false. These rules help eliminate incorrect possibilities. Hypothetical Syllogism. Suppose if P then Q, if Q then R, then we can conclude if P then R. This rule links two conditional statements together. Disjunctive Syllogism. Suppose either P or Q is true. P is false, then Q must be true. These rules help us make conclusion when only one option remains. Formal proof method involve proving conclusion through a sequence of logical steps. Every step follows from earlier statement using valid rules of inference, making the reasoning precise and reliable. Formal proof reduce errors and make reasoning transparent. They are widely used in mathematics, philosophy, computer science, and artificial intelligence. So far, we have worked with whole statement. Now, we will study predicate logic, where we describe properties of object using quantifiers such as all and some. The universal quantifier represents through the symbol upside down A. This means for every or for all. For example, all birds have feathers. Symbolically, we write universal quantifier x, comma, bird bracket x, conditional symbol has feather bracket x. This means for every x, if x is a bird, then x has feathers. A universal statement claims that every member of a group satisfies a particular condition. If even one member does not satisfy it, the statement becomes false. The existential quantifier, written as mirror image of E, means there exists or at least one. For example, some students play footballs. Symbolically, this written as existential quantifier x, comma, student bracket x, connective symbol plays football bracket x. This means there is at least one x is a student and x play footballs. Universal quantifier refer to every object in a group. Existential quantifier refer to at least one object. Understanding these differences is essential for accurate logical reasoning. Many everyday sentences can be translated into logical symbol. Predicate logic include special inference rules for working with quantifier. These rules allow us to move safely between universal existential and specific statement. Universal instantiation says that if something is true for everyone, then it must also be true for any particular individual. This let us apply general rules to specific cases. Existential instantiation states that if at least one object exists with a certain property, we may include a specific example while continuing the proof carefully. Predicate logic extends propositional logic by describing objects, their properties and relationship. It is much more powerful because it can express detailed information about the world. Predicate logic is widely used in mathematics, artificial intelligence, databases, programming language, and automated theorem proving. Venn diagrams are visual tools that represent relationship between different groups or sets. They make logical reasoning easier to understand. Each circle represents a set or category. Overlapping region show members shared by multiple sets, while separate region represent differences. A statement like all cats are animals is shown by shading the regions where cat exists outside the animal set. This indicates that such a region is empty. A statement like some birds can fly is represented by placing an X in the overlapping region, showing that at least one object exists there. We first draw the premises on the diagram. Then we check whether the conclusion is already represented. If it is, the syllogism is valid. If not, it is invalid. Suppose all mammals are animals, all dogs are mammals. The Venn diagram clearly shows that all dogs are animals. The conclusion follows naturally from the premises. Venn diagrams simplify complex logical relationships. They provide a visual method for checking argument and help students avoid common reasoning mistakes. If you are still watching, I hope you are finding this content useful. Please like and share this video. Subscribe to the channel and share your thought in the comment. Your support motivates me to create even more content like this.